In this video, let us understand about skewness. In a symmetrical distribution, mean, median and mode are all equal. If they are not equal, then there exists a skewness. There are two kinds of skewness. One is called as positive skewness and the another is negative skewness. Let us consider an example. Most of the players scored 40 plus run in a match and only a few of them has scored less than 10 runs. That means we observe that most of the players have secured more than 40%, whereas very few of them have scored less than 10 runs. So this can be represented in a graphical manner in this way. So here we observe that the frequency curve is said to be negatively skewed if the more values are found to the left side of the mode. If the more values are found to the left side of the mode, then we say that there exists a negative skewness. In the negative skewness, mean will be lesser than the median value and median value will be lesser than the modal value. Let us consider what is a positive skewness. Suppose if I say in this way, most of these players score poorly while just a few of them perform well. If I say like that, that means that most of the players could not perform well and then very few people have scored very well. In that case, I can represent the graph in that way, in this way, and then I can call this type of distribution as positively skewed. So in the similar way, I can also say that most of the students could not perform well in the examination and very few have scored better in the examination. That is also an example for positive skewness. In the positively skewed curve, we will have the mean will be the highest value and then median and mode will be the lesser than the mean value. So now there are three different measures to find out the skewness. So one is given by Karl Pearson method, then Bowley's method, and the coefficient of skewness based on the moments. In this video, I will say how to find out Karl Pearson coefficient of skewness. So here, if you have got an individual observation or if you have got a raw data or the discrete data or a continuous data, for every data, the Karl Pearson skewness is given by Sk is equal to mean minus modal value divided by standard deviation. Suppose we have got median value, then we can also find the Karl Pearson coefficient of skewness by using the formula skewness is equal to 3 times x bar minus median divided by sigma. Here x bar denotes the average and m denotes the median and then sigma denotes the standard deviation. So if the calculated value is greater than 0, then we say that there exists a positive skewness. If the calculated value is less than 0, then we say that there exists a negative skewness. If the calculated value is equal to 0, then we say that there exists zero skewness or the curve is symmetrical. Let us understand with the help of an example. Here we have got data, so for which the mean is 30 and the calculated value of mode is 26.8 and the variance is 64. We want to find whether there exists a skewness or not. So given the values are like this, so mean is 30, mode is 26.8 and variance is 64. Therefore, the standard deviation is 8. So now let us use the formula given by Karl Pearson. Skewness is equal to mean minus mode divided by standard deviation. We calculated the value and this is 0.40. So since 0.40 is greater than 0, we say that the distribution is positively skewed. So here is one more example. The number of accidents reported at city hospital in a week are as follows. As you can see here, 40, 62, 40, 25, 40 and 34 and 60. These are the number of accidents reported in a city hospital. Let us see whether there exists a skewness or not. So to find out the skewness, let us find first the average value. So average is x bar is equal to total of x divided by n, which is equal to 43. That means the average accidents happened in the city hospital, reported in a city hospital, is 43. Now let us find the standard deviation in the accidents. Then we use the formula root of x square divided by n minus total of x divided by n whole square. So substituting, we get 12.43 as the standard deviation. So here we can see here 40 is the most repeated value. So hence modal value, let us consider it as 40. So now let us apply all these data in the formula. Sk is equal to mean minus mode divided by standard deviation. We get 0.24. That means the skewness is positively distributed, or the data is positively distributed, or the distribution is positively skewed. So now let us find the skewness for the discrete continuous observation. So here we have got the monthly income distribution of 100 persons living in a village. So these are the monthly incomes. So we have got 12 persons whose income is 0 to 10,000 and 18 persons whose incomes are between 10 to 20,000. Like that the data is distributed. We want to find the skewness in the monthly income. So here we observe that the highest frequency is 27. Therefore, we say that the modal class is 20 to 30. So once we identify the modal class, we want to find the mode. So we use the formula mode is equal to L plus F1 minus F0 divided by 2f1 minus f0 minus f2 multiplied with class interval, where f1 is the frequency of the modal class, f0 is the frequency preceding the modal class, and f2 is the frequency succeeding the modal class. So identify all the values. So here lower limit of the modal class is 20, and then number of class interval, the size of the class interval is 10, and then f0 value is 18, and then f1 value is 27, and f2 is the frequency succeeding the modal class, which is equal to 20. So substituting all these values, we get the modal value as 25.625. So then we shall also find the average number of of the income. So that is given by total of f into x divided by n, which is equal to 28,000. This is the average income. So then we shall use the formula standard deviation is equal to root of f into x square divided by n minus of x bar whole square. So substituting all this value, we get 14.11. Then the Karl Pearson coefficient of skewness is given by the formula xk is equal to x bar minus z divided by sigma, where x bar is the average, which is equal to 28, and z is the modal value, which we found to be 25.625, and divided by the standard deviation, which is 14.11. So substituting, we get 0.16832. So here, since sk value is greater than 0, we can say that the given distribution is positively skewed. So now let us find the skewness for the discrete observation. So here we have got age and the number of persons. So we have got 3 people whose age is 20 years. We have got 61 people whose age is 30. Like that, the data set is given to us. So we shall find the skewness in the age. So here let us construct a table x, F is the number of persons, that's a frequency. Let us find out x square, that is 20 into 20, we get 400. 30 into 30, we get 900. Let us like that. Let us find x square of each individual x value and then multiply f with the x and then construct a column for f into x. So similarly find out f into x square and then find the total of fx square as well as total of fx as well as total of f. So this says that there are 543 persons are included in this data set. So after that, let us find out x bar, that is the average age which is given by total of fx divided by n. So we get the average age as 49.779. So now let us find standard deviation in the age by using this formula and let us substitute all the values, we get the standard deviation as 11.90 years. So let us find the mode. So modal value, why here mode is 50? Because 153 is the highest frequency. Hence here modal value is 50. So after substituting all these in the formula for the Karl Pearson coefficient of skewness, we get the SK value as minus 0.0185. That means since SK value is less than 0, we can say that the distribution is negatively skewed. This is how we find the skewness for the individual, discrete and continuous observation by using Karl Pearson coefficient of skewness